Today we look at indices. We look at the introduction of indices. What is indices? How did it came out of? Did it came to mathematics to disturb you? Did it just came to affect you? Why is it important? So we want to answer all these questions in this video. Now, first of all, say that indices is a branch of mathematics that deals with power. So indices is a branch of mathematics that deals with power. Now, let me just take note of that so that we can start with it. So indices is a branch of mathematics that deals with power. Alright, so indices is the branch of what? Mathematics that deals with what? Power. Now, indices came out from the word index. Indices is the plural form of index. And what does index mean? Index means power or what? Exponent. So another name for power or exponent is what? Is index. So indices. So indices is the plural. Is the plural of index, yeah, which is equal to what? Which is also equal to what? Exponent. It's also equal to exponent. So that's what we have traced down now. So indices that we are studying. So what does you understand? What do you understand by that stuff? You have been meeting mathematics as 2x plus 4 equals to x, or 2x minus 1 equals to 7. You're meeting this kind of mathematics. This is also what of if you meet mathematics like 8 raised to the power of 2 over 3 over 2? Or you meet mathematics as 64 raised to the power of minus 2 over 8. How will I solve this kind of mathematics? Now that's what led us to what? Indices. So indices is a branch of mathematics that now started to analyze how can we approach this? How will we approach this in a very good way? Now that's indices. For somebody to study indices very, very well, somebody must know the laws of indices. These are the first thing that you must take note of. The laws of indices. Now, for indices to be studied properly, for indices to be studied properly, a vital knowledge of the laws of indices must be inculcated. So I must know the laws of indices. It's a must that you will do. It's a must that you understand it. And that's what we want to look at. So I want you to pay attention because now this one is the art of indices, the laws of indices. There are 7. So the 7 basic laws of indices. That's what we want to look at. The 7 laws of indices. So if I write 7 laws of indices. So the first one, as we are writing it, we are proving it. How is now the first law, which a lot of people can call it the addition law, or somebody can still call it from the aspect of the reactant, the aspect of the left-hand side of the equation, the multiplication law, state that if A raised to the power of m times a raised to the power of n is equals to a raised to the power of what? M plus n. M plus n is equal to that. A raised to the power of m times a raised to the power of n is equals to what? A plus what? N. U plus is equals to that set. If the powers are, if the bases are the same, I can add the word to the powers. If they are multiplying, if they are multiplying. Now let me prove this law. If I will decide to prove that, let me take 2 as the base. 2 raised to the power of 3 times 2 raised to the power of 2. According to the law, it is equals to 2 raised to the power of what? 3 plus what? Plus 2. Right? Now let me solve. Let me know if it's the same thing. Now 2 raised to the power of 3 is actually 2 times 2 times 2. 2 in what? In 3 places. 2 times 2, 4. 4 times 2, what? 8. So if I add that, so this is 8 times 2 raised to the power of 2 is 2 times 2. And that's 4. Equals to 2 raised to the power of 3 plus 2 is 4. Is 5. So it's 5. 8 times 4 is what? Is 32. 2 raised to the power of 5 is what? Is 32. So they are equal. We do all the rules, but what the rules to be, so they are equal. They are equal. So it means that the first law states that if I have the same base, a base that are the same, I can add the powers if they are multiplying. So you don't need to do this anymore. Unity has given you option. It's giving you a very, very good way to do it. That you can just go direct, add the powers, and you are free. So that's the first law of indices. Now the second law of indices states that if a raised to the power of m divided with a raised to the power of m is equals to a raised to the power of m minus what? Minus n. That's the second law of indices. A raised to the power of m divided by a raised to the power of n is equals to what? A raised to the power of m minus what? M. So if I want to prove that also, let me just take that same number. 2 raised to the power of 3 divided with what? 2 raised to the power of 2 is equals to 2 raised to the power of 3 minus what? Minus 2. 2 raised to the power of 3 is what? Is 8. Divided with 2 raised to the power of 2 is what? Is 4. Is equal to what? 3 minus 2 is what? Is 1. So we have 2 raised to the power of 1. 8 divided by 4 is what? Is actually 2. Now 2 raised to the power of 1. Anything raised to the power of 1 is that same number. Is 2. So 0 plus confirm. Alright? I'll confirm that this is actually what? Equal. 2 is equal to what? Is equal to is equal to 2. Alright, so that's the second law of indices. That if I have division and I have the same base, I can do what? Subtract the powers. Subtract the powers. So another law states, number 3. Another law states that if I have a raised to the power of 0 is equal to 1. Anything raised to the power of 0 is equal to 1. 1 million raised to the power of 0 is actually equal to 1. It's equal to 1. 90 raised to the power of 0 is equals to 1. 100 raised to the power of 0 is equals to 1. Anything that is raised, number that is raised to the power of 0 is actually equal to what? It's equals to 1. So that is the third law of indices that we are noted. Now, we saw another law. Number 4. We have that a raised to the power of n bracket n. Now it is equal to a raised to the power of n times n, which is equals to a raised to the power of n. So that's the law. So I can state it this way that 2 raised to the power of 2 bracket 2. So these 2 will not just come and stay here. Or let me use 3 for example. Let me use 3 as the power. So 2 raised to the power of 2 bracket 3. I will not come and okay. 2 raised to the power of 5. No, if you do that, you are wrong. Don't try that. Now, the best method you need to do is that I will multiply it. 3 will multiply the power. I will not come and do 2 raised to the power of 2. Then it was 2 raised to the power of 3. You stay wrong. Don't try that. Now, the thing that I will need to do based on this law is 2 raised to the power of 2 times what? Times 3. And which is equals to what? 2 raised to the power of what? 6. Now I can write my answer as well, 64, if I want to see. So that's what I just do. It must multiply. The powers will multiply. Brackets, no in fraction, each fraction, brackets is about what? Multiplication. All the maths. So we multiply. So if I want to write it. Number 5. I know that a raised to the power of minus 1 is equal to what? 1 over a. In other way around, if I will write this, I can write that 1 over a. If I will write this, I have 1 over a is equals to a raised to the power of minus 1. Well, so if I have a number raised to the power of -1, I can inverse the number. 10, 1 over 10 is equals to 10 raised to the power of -1. 1 over 4 is equals to 4 raised to the power of -1. 1 over 2 is equals to 2 raised to the power of -1. So that's what it is. It's equal to that. It's equal to that. So any number that is at this state, I can raise it to -1 if I have 1 over it. But what of if I have 2 raised to the power, that's if I have 1 over 2 raised to the power of b? What will it be? What will it be? So it's still the same thing. It's still the same thing. It's now equals to 2 raised to the power of 4 and then minus b. Because that -1 will times b, and that will be minus b. You get what I told you? So it's still the same thing. Now, as we explore the world of indices, we start to deal with those stuff accordingly. All right. So number 6. Number 6. We have number per state. A raised to the power of n divided by n is equal to the square root of n, then a raised to the power of n. So that's number 6, the law of indices. So we can still prove that if I have let me take 64, I have 64 raised to the power of 2 over 3. They told me that I can write it. So let me bring it here. Let me bring it here. I have 64. I have 64 raised to the power of 2 over 3. I can write it as root of 64 square. Square, that's the 2 square. This, that's what the law is telling people. I can decide to move this and move outside the bracket. It's here as I can still decide to put it in there. I'll say I have the same. Now somebody can solve this. This is 4. This is 16, right? So you can solve it. So when you see question like this, don't be afraid again. Indices has given us the law, and we can set the value. All right. Now we have the final law of indices, the 7th law, so that we can enjoy the law of indices accurately. Given that a raised to the power of minus x minus x, given that a raised to the power of minus x is equals to 1 over a raised to the power of what? X. Now this brings us back to this state. So it's still the same thing when we still apply it at this state. So it brings us back here. So all those things are just at their own pace. So they are still the same thing that the raised to the power of minus x is equals to 1 over what? X. If you have understood it, it's time for you to now await the next topic. the next part I need to say under indices. And what's the next part? I want to look at how to apply these indices.